Let's start real quick. Three-sided figure. Hopefully we know that's our triangle. Four-sided. That's the unit we're on, and that is quadrilateral. A lot of people say rectangle, square. Yep. That's four sides, but that's a type of quadrilateral. All right. Any four-sided figure we can refer to as a quadrilateral. All right. Probably some of the newer ones. Maybe, maybe not. Anybody know five sides? That is a pentagon. How about a six? Hexagon. Anybody know seven? There's actually two names I found out. The one we're going to use is heptagon. I believe the other name is septagon for a seven-sided figure, but we're going to go with heptagon. Anybody know eight? It's not a stop sign. Octagon. One of my personal favorites, nine-sided. Nonagon. Non-agon. 10. Decagon. I skip over 11 because we're never going to have it. And go right to 12. Dodecagon. Anybody know 20? I don't know 20 either. Because once it gets above 12, here's what we start doing. 20, gone. That's what we're going to start doing. Okay? 20 gone. All right, anything above 12, we can just call the side numbers gone. So for n gone. Okay? However many sides. Let's just get in that habit. Okay. You guys have probably heard of a diagonal before, but you only know it probably corner to corner in a quadrilateral. Draw yourself a pentagon. Quick five-sided figure for me. Go ahead, draw yourself a quick five-sided figure known as the pentagon. You can have diagonals in those too. It connects two non-consecutive vertices. So somebody pick a vertice and connect a non-consecutive one. So here's a diagonal. Here is a diagonal. All right, we could draw a ton in there. Okay, so you can have diagonals in something other than a quadrilateral, four-sided figure. What do you call them if you connect two consecutive vertices? That's a side. Okay, that's a side. Two non-consecutive vertices, the diagonal. All good? All right, draw yourself another, under convex, draw yourself another pentagon. There's two types of polygons. One's called a convex, which you guys have probably dealt with your entire math career. Ones that look like this, where every diagonal can be drawn inside. All right, any diagonal I draw will be inside that pentagon. Well, how can you have a figure where the diagonal is on the outside? You guys probably never experienced that before. This is convex. Concave is where I can draw one of them on the outside. Do I have? Yes, I do. That's an arrow. It's also a polygon. 1, 2, 3, 4, 5, 6 sides. 6, did I count them all? 1, 2, 3, 4, 5, 6, 7. 7 or 6? 1, 2, 3, 4, 7. So there's a heptagon right there for you. Do you see a diagonal I can draw on the outside that connects two non-consecutive vertices? Here you go. There's a diagonal on the outside. Here's another diagonal on the outside. Okay, that is a concave polygon. Concave. See the difference between convex and concave before I go on? How many degrees in a triangle? 180, we all know that. How about in a quadrilateral? 360, some of us know that. Anybody know how many degrees in a pentagon? Octagon? Decagon? That's your goal today. You and your group right now are going to figure out how to find the degree measures in those and see if there's a pattern. So what we're going to do, we're going to fill in this table. All right, we're going to talk about 5 different figures right now. You're going to talk about the triangle, the quadrilateral, the pentagon, hexagon, and octagon. You're going to fill out the number of sides for each. Shouldn't be an issue there, right? We just went over all the names. So for triangle, there's 3 sides. Now it says number of triangles formed. Well, for the triangle, there's only 1. And what's the sum of the interior angles? 180, right? That's not too bad. We don't learn much from that. Okay, let me do quadrilateral with you, and then you and your group do pentagon, hexagon, octagon. All right, quadrilateral, how many sides? 4. Here's what I mean by number of triangles formed, and this is what your group's going to do for the other 3. There's my quadrilateral. Starting from one vertice only, how many diagonals could I? So if I start from this vertice only, how many diagonals can I draw in? Just that one. Don't tell me 2, because you have to start from one vertice only when you make these triangles. How many did I form? 2 triangles. And how many degrees are in each triangle? In each triangle, 180. That is where you get that the angles inside a quadrilateral add to 360. So that's what you're going to do in your group right now. I'm going to give you about 2 more minutes here. Draw a pentagon. See how many triangles can be formed from one vertice. And then say, all right, each triangle is 180 degrees. So what's the total amount of degrees in a pentagon? And then see if you can find a pattern at the end. Here you go. Get going here. And yep, you're going to have to actually speak to your new group members. Might be difficult. Here we go. Pentagon, 5 sides. How many triangles did it form? 3, and all of them have 180 degrees. So how many total degrees in a pentagon? 540. Nice job. We know a hexagon's got 6 sides. How many triangles did it form? 4, all totaling 180, so 720 degrees. Let's keep this train rolling. One more. Octagon's got 8 sides. How many triangles? Woo, okay, a little pattern there. So 1,080 degrees. What's the pattern here? So right now, hey, I don't want you to draw it. What if I did say a 15 gon right now? And I said 15 sides. How many triangles should it form? No, all on our pattern here. Make sure you tell them I said hi. 13. All right. Each having 180 degrees. So how many angles in a, what do all the angles add up to in a 15 gon? 13 times 180. Go ahead. Woo! 2,340 degrees. All right, so let's put this into a theorem now. Anybody want to describe how you can find the interior angles of any polygon? So the sum of the interior angles of a polygon. What'd you guys do? Talk to me in words. What did you have to do? And I will hear from number 1, the new number 1. What'd you have to do, Matt? What's the pattern?
You have to subtract 2 from the number of sides to get the number of triangles.
And then do what with that number?
And then multiply that number by 1.
Perfect. Here's how we're going to write it. 180 times n minus 2. Any ideas what n represents? Number of sides. That is to find the interior angles, what they all add up to. All right. 2 minutes. That's all I can give you here. 2 minutes for numbers 1 and 2 right now. Find the interior, sum of the degrees of the interior of 100 sides, and then the missing angle here. You and your group. Here you go. Make sure you all agree at the end. Number 1 here, 100 sides. How'd you find it? I don't want to know the final answer. Just want to know what you used to find it. Here you go. 25. 100 sides minus 2, got it. And then we end up getting what for our degree measure there, Mason? There you go. Any issues with that one? Okay, and then finally find the missing angle here. All right, quick question for somebody here. Number 8, how many sides did this have? Okay, not here today, good. How about 22? How many sides? 5 sides. How many degrees total in a 5-sided figure, Emma? 540. All right, so we took 540 and subtracted the other 4 angles that we had. Emma, what'd you guys come up with back there? 103 degrees, yep. Questions at all? There's a pattern for the interior angle, so you would assume there's a pattern for the exterior ones on the outside, and you are correct. There is a pattern, but just like interior, you're going to find it yourself. So here's what I'd like to do here. Group 1, which consists of these 3 groups right here. You are going to take this figure, and you are going to find every exterior angle. And I want to know what they all add up to, the exteriors. Now, quickly, before I assign group 2 and 3, 150 and its exterior should add up to what? 180. They're linear pairs. Okay. I don't want to know what they are. I want to know what they all add up to at the end. That's your goal. Group 2, you guys right here, you got the figure in the middle. And group 3, you guys have the triangle. Find each exterior angle and let me know what they all add up to. Okay, so group 2, you should be finding 4 exterior angles. Group 3, you should be finding 3 exterior angles. Tell me what they add up to. That's all I'm concerned about, is what their sum is. And converse in your group, make sure you got the same sum. Okay, let's get group 1. I don't care, anybody from group 1 here. These 3 groups, what do they all add up to?
360.
Group 2. Huh. And the final group over here. What am I trying to show you here? Does it matter how many sides a figure has? No, all exterior angles will always add up to 360, no matter the number of sides. Okay? So there's no fancy formula. Here you go. The sum of the exterior angles of a polygon no formula. What is it? Yeah, 360. That's all of them added together, always 360. Interior, 180 times n minus 2. Exterior, always equal to 360. So can you answer number 3 in about 5 seconds? Find the sum of the measures of the exterior angles of a polygon that has 36 sides. What's the sum of the exteriors now if I have 36 sides? Number 1, Matt, again, you're on fire today. Guys, I could change that 36 to a 50, to a 100, to a 2,000. It doesn't matter. The answer is always going to be 360 when it's the sum of the measures. All right? Questions? Last thing we got to do. All right, I can find out what all of them inside add up to, but can you just find one of them instead all of them? All right, can you find just one interior angle for me? All right, you know how to find what they all add up to? How can you find what just one of them is? Regular polygon first. Let me give you an example of a regular polygon, and maybe you can give me the definition. A square is a regular polygon. What's so fancy about a square? Okay, so in a regular polygon, all sides congruent. So if you have a regular pentagon, that means all 5 sides are congruent. What else is fancy about a square? All sides are equal? All angles are equal too. So ready, in a regular polygon, all interior angles congruent, and also all exterior angles congruent. All right. Find one exterior, one interior for a 20-sided polygon. All right, let's get, who's going to help me first here? 17, where's 17? 17? Okay, Catherine, here you go. Let's do exterior first. What do all of them add up to? Okay, so I know they all add up to 360, and how many of them are there, Catherine, in this case? 20, and since it's regular, what do you know about all 20 exterior angles? So what can I do with that 360 and 20? Like, there you go, 360 divided by 20. And what do you got for me? Bless you. 18 degrees. One exterior angle, 18 degrees. Nice job. Everyone all right on that? Little tougher for the interior. Who's got 18 now? 18. Okay, Bella, here we go. Interior angle. You all know all the exteriors add up to 360, right? How can you find what all the interiors add up to? What formula did I give you already today? So 180 times how many sides here? 20 minus 2. Go ahead, find all the interior angles added up. $3,240. That's what they all add up to. I just want to find one. How many interior angles are there? 20. So what can I do with the 3,240 and your 20? Divided by 20. So what's one interior angle? 162. Now let's just talk before we go on to the next one. Because if Bella wanted to, she didn't have to do it this way. Remember when we found the exterior angle was equal to 18? What's the relationship between the exterior and the interior? Go back. Hey, what did you guys do here? What's the relationship between an exterior and an interior? 180. So once I found 18, I could have subtracted that from 180 to get the interior. So just make a note on that problem right there, please. Make a note. Interior angle plus the exterior is equal to 180. They're supplementary. That may help you out. Okay, that may help you out. All right, let's find the number of sides now. I'm going to do 5 and 6 with you, and then I'm going to leave 7 in your group. All right, number 5, find the one exterior angle measures 120. How many sides does it have? Okay, one exterior measures 120. How many sides does it have? All right, who's helping me with this one? 13? 13? 13, Emily? All right, ready to roll? What do you know about the exterior angles? What do they all add up to? They all add up to 360. Each one of them's 120. What can I do with the 360 and the 120 to find out how many of them there are? They all add up to 360. Each one, because it's regular, is 120. There you go. 360 divided by 120. How many exterior angles are there, Emily? 3, which means there's 3. If there's 3 exterior angles, that means there's 3 sides. It's a triangle. Everyone see where that came from? 360 degrees total, 120 in each of them, so I divided them up. All right, a little different now. Instead of giving you the exterior, I'm going to give you the interior, number 6. One interior angle is 160. How many sides does it have? And I don't want you to guess and check. This one's a little tougher. It's a little tougher. Oh, Matt, you're on fire today. Ready? I'm just going to ask you a couple questions to get there. I don't expect you to get there on your own. Maybe you could. I believe you could, though. What's the 160, Matt? What's that telling me, that 160? So one interior angle is 160. So guys, I don't know how many sides it has, but I know each interior angle is 160, 160, not drawing the scale, 160. Okay, and I got to know how many sides it has. Okay, Matt, I don't care about the interior. Ready? If one interior is 160, can you find me the exterior?
Yeah.
It's 20. Everyone agrees? One exterior is going to be 20. Why is that so helpful to us? Matt, don't I know what all the exteriors add up to? They add up to 360. I may not know what all the interiors add up to, but at least I know the exteriors add up to 360, and they're all 20. So what can I do with the 20 and the 360? Great job, Matt. 360 over 20. What do you got for me? 18 sides in this bad boy. Yep. 18 sides. And finally, just let me go over this one and I'll let you go to work with your group. All the angles, all the interior angles add up to 2,880. How many sides does it have? And you are not allowed to guess and check. Okay, I don't want to come around to a group and they're, oh, let's check 15, let's check 20, let's check 18. No, all right? You know all the interior angles add up to 2,880. How many sides does it have? You and your group discuss. When you think you have it, call me over. I'll check it and your work, and then you can get going on the homework. All the interiors add up to 2,880.